Hello students, welcome to the class. So the topic we are discussing now, in the previous classes we have discussed about the op-amp, where we have studied about the differential amplifiers and also the concept of slew rate, CMRR, input and output offset voltage, ideal and practical characteristics of op-amp we have covered till now, and also the pin diagram of IC packages of op-amp, where we have seen single package, dual and quad package, right? So all these topics we have discussed in the previous classes, and in the last class I have also mentioned the applications of op-amp, wherein we have seen that op-amp is used as an inverting amplifier, non-inverting amplifier, adder, subtractor, differentiator, integrator, logarithmic amplifier and anti-logarithmic amplifier, and many more applications are there. So now we are going to study these applications of op-amp, where the derivations will be there for the circuit. There will be a circuit that is going to connect the op-amp to work as an inverting amplifier, and its output derivation, otherwise its gain derivation will be there. And also about the non-inverting amplifier, the same will be studying here, right? So starting with the op-amp inverting amplifier. Op-amp inverting amplifier. So basically, what is this op-amp inverting amplifier? The op-amp inverting amplifier is a application of op-amp wherein the op-amp connected in such a manner is going to produce a output signal that is 180-degree out of phase with the input. 180-degree out of phase with the input. Otherwise, and connection otherwise and setup of the op-amp amplifier such that the input signal is applied to the inverting terminal. Okay, so the op-amp that is designed with the input applied at its inverting terminal is called as what? Op-amp inverting amplifier. Okay, op-amp is called as an inverting amplifier when the input is applied at the inverting terminal. Okay, producing an output that is out of phase by 180-degree with respect to the input is called as what? The inverting amplifier, right? So I am going to write what is an inverting amplifier. An inverting amplifier whose output is 180-degree out of phase with respect to the input. An inverting amplifier is a op-amp based amplifier whose output is 180-degree out of phase with respect to the input. Okay, or the type of op-amp amplifier type of amplifier, otherwise op-amp amplifier, in which the input is applied, in which the input is applied to the inverting terminal of the op-amp. Okay. The type of op-amp based, otherwise the type of amplifier in which the input is applied to the inverting terminal of the op-amp is called as what? Inverting amplifier. The inverting amplifier is the type of amplifier to which the input will be applied to the inverting terminal. In the previous class, we have discussed about the symbol of op-amp, where we have seen that the symbol is comprising of two inputs. One is inverting input, the next one is the non-inverting input, along with two supply voltages plus VCC minus VEE and a output. So there we have seen that the op-amp is basically having two inputs, one termed as inverting and the other termed as non-inverting. When the signal to be amplified, when the input signal that is to be amplified is applied to the inverting terminal of the op-amp, such amplifier is called as what? Inverting amplifier. Right? So this is about the op-amp inverting amplifier definition. Next we will move with the circuit diagram and the derivation for the op-amp inverting amplifier. So now we are moving with the op-amp inverting amplifier. So starting with the circuit for op-amp inverting amplifier. Inverting amplifier using op-amp or op-amp inverting amplifier. Starting with the symbol, I am drawing a circuit. This is the symbol. Symbol of op-amp, starting with the triangle, minus inverting amplifier plus non-inverting amplifier. The two supply voltages plus VCC minus VEE. Okay. Here we will take the output. The two terminals where the input is applied. The applied input is termed as VI. The resistor at the input side is called as RI. There is also a negative feedback. Okay, in the definition itself, we have studied that the op-amp is a negative feedback amplifier, right? So this is RF, feedback resistor, and the non-inverting terminal is applied at ground. Okay, so this is the circuit. This is the circuit of the op-amp. Okay, circuit of the op-amp. So basically, the op-amp inverting amplifier is comprising of two resistors, two power supplies that are used for powering the op-amp, one battery supply that is the input applied, termed as VI. The input resistor is RI. The feedback resistor is RF. The input VI is applied to the inverting terminal through R1. The feedback is taken to the inverting terminal through the feedback resistor RF. So this is about the circuit description. So how is that circuit description? The input VI is applied to the inverting terminal through RI, and the feedback voltage is applied to the inverting terminal through RF. Okay. So this is the symbol Inverting amplifier, non-inverting amplifier. What definition I told you? The input is applied to the inverting terminal of the op-amp. Such connection is called as what? Inverting amplifier. So where we are applying the input, we are applying the input to the inverting terminal. So this is the connections for the op-amp inverting amplifier. Okay. Now moving with the derivation, where we consider this point to be A. The current flowing here is input current II. Okay, to avoid confusion, I am writing this here. Alright, and the current flowing is II. The current flowing here is feedback current IF, and the current flowing here is negligible current I neg. Okay, is a negligible current I neg, right? So these are the two currents. Proceeding with the derivation, we apply KVL. Apply KCL at point A. The number of currents entering the node is equal to the number of currents leaving the node. So how we can write the expression here? II is equal to IF plus I neg. This negligible current is 0. That's why that it is termed as negligible current. And why it is 0? Because ZI, input impedance ideally for the op-amp is infinite. Hence, no current flows. I neg is equal to 0. Okay. So considering this current to be almost 0 or equal to 0, we are going to write the expression further as II is equal to IF. Okay, II is equal to IF. Now, II is the difference between the potential at V1, Vi and the potential at Va divided by Ri. V by R. I is equal to V by R. This potential Vi and the potential at Va. Vi minus Va by Ri is II, whereas Va minus V0 by Rf is IF. So that I am going to write it now. So how it can be written is equal to Vi minus Va by Ri. Okay. Potential at this point to potential at this point, the potential difference between these 2 points divided by Ri. Potential difference between these 2 points divided by Rf is equal to Va minus V0 by Rf. Okay. So this is the expression up to where we have reached now. Now, Va is equal to 0. Why Va is equal to 0? Because the current flowing there is 0. Okay, that is one of the reasons, and also the reason for this is virtual ground concept. Concept of virtual ground is going to make this Va is equal to 0. Okay. Detailed about the virtual ground concept I will be explaining next. Now we have to substitute Va is equal to 0 in these expressions. Since Va is equal to 0, what happens now? Vi by Ri is equal to minus of V0 by R. Okay, this can be rearranged as V0 by Vi is equal to minus of Rf by Rf. V0 by Vi is nothing but what? It is the ratio of output to input termed as the gain. So the gain is equal to minus of Rf by Ri. This is the expression for gain, and also from this we can write the expression for output. So what is the expression for output of an inverting amplifier is minus of Rf by Ri into Vi. These are the two important expressions for what? Inverting amplifier. Okay. Op-amp inverting amplifier, when the input signal is applied at the inverting terminal of the op-amp, it is called as what? The op-amp inverting amplifier. This is how the setup is. The input is applied at the terminal, inverting terminal, and the input applied is Vi. That is passed through the inverting terminal through resistor R1. Feedback is taken from the output to the input through resistor RF, termed as feedback resistor. This is called as input resistor. This is called as input signal Vi. Okay. Now we consider this node as A, and we are going to apply KCL to this point, and where we can see that II is equal to IF plus I negligible, I negative. Okay. So as this is negligible current, and that is due to the infinite opposition, otherwise infinite impedance offered by the input part of the op-amp, the current becomes zero, almost zero. Considering that in the expression, we can write that II is equal to IF. Now what is II? I is equal to V by R. So what is the V? V is the difference of Vi minus Va. Vi minus Va by Ri is equal to Va minus V0 by Rf. Okay. Now, Va is equal to 0. The potential at this point is 0 because further the flow of current is almost 0 beyond this. Okay. Now, substituting this Va is equal to 0 here, we are going to get as Vi by Ri is equal to minus of V0 by Rf. Rearranging this, we are going to get V0 by Vi is equal to minus of Rf by Ri, where V0 by Vi, that means ratio of output to input, is termed as what? Gain. Ratio of output to input is nothing but what? Gain. And this gain for an inverting amplifier is minus of Rf by Ri. When we want to calculate the output of this particular signal with specific value of input, then we can also calculate it by minus of Rf by Ri into Vi. This is the expression for V0. Okay. So what are we can observe here? So what is the advantage with this circuit is that whenever you want to design any value of gain, it is just the configuration completely depends upon the values of Rf and Ri. If you simply want to double the gain, then you can just take the Rf as the double value of Ri. If this is taken as 1 kilo ohm and this is taken as 2 kilo ohm, then it is going to give a gain of simply minus 2. Okay. So whenever, even if you want to take the signal with only inverted output, you do not want to introduce any gain. You don't want any gain, you just want the output to be inverted form of the input. In that case, you can take Rf is equal to Rf. So what happens here? Both gets cancelled and you are going to get a gain of minus 1. Okay. So with the gain of unity, you can just take the inverted form of the input. So if at all in any application, if you require the exact 180-degree phase shifted signal with respect to the input, you can just go for the inverting amplifier with the values of Rf and Ri is equal to as equal. Okay. So in that case, what will be the value? It is simply V0 is equal to minus of Vi. So this is simply the inverted form of the applied input. So the output will be the simply inverted form of the applied input. Okay. So this is how this particular circuit becomes very, what we can say, easy, otherwise very useful for designing amplified signal, designing for a signal with inverted output without any amplification or without introducing any gain. So this is all about the op-amp inverting amplifier, starting with the definition, the circuit, the derivation, and the output. Okay. So what we observe here, the output is minus of AI, that means inverted form of the applied input. Output is just the inverted form of the applied input. I am applying a DC voltage here. So when I am applying a DC voltage here, I consider that RF and RI are both 1, producing no gain. If the value of VI is 1, then the output value will be -1. If the value of VI DC is 2, the output will be -2. Okay, this is with applicable output with 180-degree phase shift, right? Without any gain if RF is equal to RI. With the application of AC signal, if I am going to apply an AC signal like this, it is going to give a exactly same in magnitude but 180-degree phase reversed signal in the output. With the application of DC, if 2 volts, output will be -2 volts. Then RF is equal to RI. When no gain is introduced for the inverting amplifier. So this is all about the inverting amplifier. This inverting amplifier is very often asked for 5-mark questions, the derivation, and also all the derivations and the circuit specially plays a very important role in solving the numericals for 5 marks. Okay. Upon this expression and understanding of the circuit, you can only solve the numericals when you understand the connections, because there the circuit will be given where you have to identify if the given circuit is an inverting amplifier or the non-inverting amplifier. Depending upon that, applying the expression remains there. Okay, and after that you have to substitute the values to compute the final output. Right? So complete set of combination of inverting and non-inverting amplifiers will be asked there, where stage by stage you will have to solve it. So for that, recognizing the plays a very important role. So remembering this circuit is also very important. Just you have to see where the input is connected. Input is connected to inverting terminal, it is an inverting amplifier. Input is connected to non-inverting terminal, it will be a non-inverting amplifier. Okay. So it is very important for final numericals and non-inverting amplifier. Op-amp, non-inverting amplifier. So now we are discussing about the op-amp non-inverting amplifier, where the op-amp non-inverting amplifier can be defined as the amplifier where the input and output are in phase. The op-amp based amplifier called as non-inverting amplifier is having the input and output in phase. Also, the op-amp based amplifier in which the input is applied to the non-inverting terminal is called as what? Op-amp non-inverting amplifier. Okay. So the definition, in which the output is in phase with the applied input. Okay. Op-amp-based amplifier in which the output is in phase with the applied input, or again op-amp-based amplifier only in which the input is applied to the non-inverting input terminal. Amplifier, otherwise op-amp-based amplifier in which the input is applied to the non-inverting input terminal. Input is applied to what? The non-inverting terminal. Such connection, otherwise such amplifier will be called as what? Non-inverting amplifier. Now moving with the circuit and the derivation for the non-inverting amplifier. So what we say about the non-inverting amplifier here, that the two signals, the input and the output, are both in phase. Both are in phase. So now proceeding with the circuit connections. Starting with the op-amp again. Starting with the symbol of op-amp. Minus, plus. This is where the input is applied. VI. This point is rounded. RI, RF, V0, VI with plus VCC and minus VEE. With plus and minus VCC and VEE. So this is the circuit connection for non-inverting op-amp based non-inverting amplifier. So about the circuit of connections, basically there are two resistors, one connected to the inverting terminal and one from the output towards the inverting terminal. Okay. The next one is the non-inverting terminal where VI is connected. Okay. So just a small concept I am explaining you here, where basically when the op-amp is powered, the VI, as we know, the op-amp is a differential amplifier. One of the terminal is at 0 and the other terminal is at input voltage VI. The two differences of the input, that is VI minus 0. That means VI reaches the output. Okay, VI reaches the output, and the same VI is applied to the feedback. So the potential at this point A is VI. Okay, it is a differential amplifier. VI minus 0 because non-inverting, the inverting terminal is applied with ground 0. Non-inverting terminal is applied with the VI. This VI reaches the output and the portion of the output is fed back to the inverting terminal. That's why the potential at the point VA is equal to VI. Okay, understanding this is very important to derive the expression. Okay, so previously in the non-inverting, in the inverting amplifier, the potential at this point was 0. Okay, but at this point the potential is VI, right? So we are going to write the same expressions now. I negligible, I F. Again applying KCL. KCL at A. I is equal to IF plus I negligible, where I neg is 0, so we get what? I is equal to IF because I neg is equal to 0. Okay? Now, I is equal to 0 minus VA by RI. 0 minus VA by R is equal to V0 minus VA by RF. V0 minus VA by RF. This could be written as minus of VI by RI. Why? Because I explained just now that VA is equal to VI. So that same thing I am substituting here is equal to V0 minus VI by RI. Okay. Rearranging this minus RI by RI is equal to V0 by VI minus V0 by VI. I'm just expanding the term, otherwise splitting will happen. Okay. So how this can be further written as? This can be written as 1. Okay. V0 by VI. I'm keeping it here only. I'm keeping this term here where both the terms are minus, so minus just comes out. Okay. Keeping this here is equal to 1, otherwise RL plus RI plus 1 is the expression for the output. Okay, gain V0 by Vi is equal to RF by RI. Okay, if you did not understand this part, taking this here, taking that there, and it is going to become what? The signs are going to be cancelled, right? So this is about the expression for non-inverting amplifier. So this is nothing but gain. AV is equal to 1 plus RF by RI. Gain is equal to 1 plus RF by RI, where the V0 can be also written as V0 is equal to 1 plus RF by RI into VI. Okay. So this is about the circuit, where the circuit says that the potential at VA is equal to VI. So we are applying II is equal to IF, otherwise we can just write IF is equal to II. Anyway, you can solve it. So when II is 0 minus VA by RI. Okay? Oh, sorry. I just wrote this reverse. This is VA minus V0. I have taken the feedback path here. Okay. So this is VA minus V0, not V0 minus VA. VA minus V0 by RF. So that is going to give you what? VI minus V0 by RF. So this is going to become what? 1 minus V0 by VI. Okay, or VI by VI minus V0 by VI. So I just wrote it in the opposite form. So this is going to be now this way, where if I take this term V0 minus VI this side, and if I take this term RF minus minus of RF by RF that side, so both the minus signs will be cancelled. Okay. So writing this V0 by VI here and taking the RF by RF that side, both the terms have become positive now. Keeping VI by VI, that is equal to 1 in its original position. That's why V0 by VI is equal to RF by RI plus 1, where V0 by VI is open to gain, otherwise gain, that is the ratio of output to input, AB given by 1 plus RF by RI. V0 is equal to 1 plus RF by RI into VI is the expression for V0. So this is giving you expression for output without any minus sign. That's why the output is exactly in phase with the input with some gain. With some gain. Okay? So this is the circuit. This is the derivation. I will just repeat it once again. The circuit with the circuit symbol of op-amp, where input is connected to the non-inverting terminal, and I have explained you why the point A became potentially VI, why the potential at the point A become VI. Okay, that also I have explained you. Here, the resistor is connected to the inverting terminal and another resistor is connected from the RF. Proceeding with the same concept as we have used in the inverting amplifier, we followed with the application of the KCL at node A. With the application, II is equal to IF plus I negligible, where I negligible is considered to be 0. We came up with II is equal to IF, where we came to the expression of voltage versus otherwise voltage by resistance, where the voltage across this resistance R1 will be 0 minus VA. 0 minus VA by RI is the expression for II, whereas VA minus V0, not V0 minus VA. I just wrote this reverse. Okay, VA minus V0. Okay, VA minus V0. Otherwise, V0 minus VA will be minus of IF. We have to take IF. VA minus V0 by RF. We have to write it. Then we have to substitute the value of VA, where I have explained that the potential at the point A for the non-inverting amplifier is going to be VI. So we just substituted the value of VI in the place of VA. Right? And we came with the expression as minus of VI by RI is equal to VI minus V0 by RF. When we just rearranged it, we shifted the RF to the position of VI and VI is taken in the place of RF. Then it became RF by RI is equal to VI by VI is equal to 1 minus V0 by VI. Okay. Finally, rearranging the expression for V naught by VI is equal to AD. We get it as RL by RI plus 1 or 1 plus RL by RI. Rearranging this expression for the output expression, we can write the output as V naught is equal to 1 plus RL by RI into VI. These are the two important expressions where the first expression gives you the gain of the non-inverting amplifier, whereas the second expression is going to give you the output of the non-inverting amplifier. Right? So this is the complete derivation for the non-inverting amplifier. Next, moving to the further topics. So we have derived the expression for op-amp inverting amplifier and op-amp non-inverting amplifier. We have derived the expression for gain as well as output of the two circuits. Now the next thing is buffer amplifier, also called as unity gain amplifier and also called as voltage follower. Voltage follower means the output is exact replica of the input in terms of magnitude and phase. Okay, the magnitude as well as the phase of the input and output signal should be exactly same. Such amplifier is called as what? Voltage follower, buffer, or unity gain amplifier, which is not going to introduce any gain. Buffer, voltage follower, unity gain amplifier. So what is the definition? This is the type of amplifier which is not going to introduce any gain and it is not going to produce any phase difference. The input and output for the voltage follower, buffer, or unity gain amplifier are exactly same in terms of magnitude as well as phase. So the phase and magnitude of the input and output of a buffer amplifier are exactly the same. Okay, so I'm starting with the circuit now. Where the input is applied to the non-inverting terminal. This is the input, and the feedback is applied to the inverting terminal. So it is basically a non-inverting amplifier concept where the value of RL is 0, value of RL is 0, and the value of RI is infinite, because when there is no resistor connected, we are going to consider the input impedance of the op-amp, where the input impedance is going to be infinite. Okay. So this is the output V0. This is the input VI. Okay. And the output is exactly the same as the input. So the concept here is V0 is equal to VI. V0 is equal to VI. Okay. So considering this as a non-inverting amplifier, the gain of non-inverting amplifier is the gain of non-inverting amplifier is AD is equal to 1 plus RF per RI. Okay, where we see that RF is 0 and RI is infinite. AB. So this can be further written as AB is equal to 1. That means gain is 1 for the buffer or voltage follower or unity gain amplifier. And AB is V naught by VD is equal to 1. So this can be written as V naught is equal to VI. So what does it say? It is just the voltage follower, otherwise simply a unity gain amplifier that in which the output is exactly equal to the input in terms of the magnitude as well as in terms of the phase. So there will be no change in the magnitude or phase of the per and voltage follower, buffer or unity gain amplifier. So this is about the voltage follower. So what all we have discussed now? We have discussed the inverting amplifier, non-inverting amplifier and the voltage follower. 3 circuits we have discussed now. Now, the next topic I will be discussing is the concept of virtual ground. First thing, the concept of virtual ground is only applicable to the inverting amplifier. It is only applicable to the inverting amplifier. Okay. So I am considering the circuit. The signal is applied. The feedback is taken. And the non-inverting terminal is at ground. Non-inverting terminal is at ground. And we claim that the potential at this point is the potential at the point A is 0. That means virtual ground concept. Okay, concept of virtual ground. Concept of virtual ground. That means virtual means it is actually not physically existing there. It is not physically connected to the ground, but the potential at that point is definitely almost 0. Okay, so the concept of virtual ground. So, what is the concept of virtual ground? It is the situation in an op-amp where the point at the inverting terminal is having a potential at 0, but it is actually or physically not connected to the ground. Okay, having the potential at this point as 0. It is a situation where the input terminal, the inverting input terminal of the op-amp is said to be at the potential as 0, where it is not actually or physically connected to the ground. Which is physically not connected to the ground, but its potential is at 0. Okay. So this concept is called as what? Virtual ground concept. Now, how this happens? See how this happens. I am going to apply a signal here. Okay, and I name it as Vi. So this Vi travels through the Ri and it reaches internally to the V0. Okay, where internally this is a differential amplifier. It is going to be what? V2 minus V1. That means the potential at this point is 0 minus V1 means Vi. So output produced will be minus Vi. and this same minus Vi is applied at the feedback by the RF. So what is happening? The net effect of the Vi and the Vi and minus Vi, the algebraic sum is going to be 0. Algebraic sum of the two voltages at point A are going to be 0. Okay. Sum of the two voltages at point A will be 0. Okay. That's why even though we are not connecting any physical ground at this point, the point is still said to be at potential 0, or as what it is called as virtual ground. Okay, this is called as what? Virtual ground. We are going to receive the signal as the inverted form. So the net effect at the point A due to the Vi and minus Vi is going to be what? 0. Okay. So this is the concept of virtual ground. So this is about the concept of virtual ground, and there is also the concept of virtual short. Where in the virtual short, it is saying that when the two applied signals, that means V2 minus V1, both are equal. Okay, there exists a virtual short. Okay, virtual short is the condition where the two signals, input signals, are exactly equal. Okay, and how they explain this? They explain this with the help of the circuit. The two inputs V1 and this is V2. The input impedance is Zi. Okay. Here we are going to get the output. Okay. What they say, as it is a differential amplifier, voltage differential input. Okay. What is the gain of the differential amplifier? AB is equal to V naught by differential input. Okay. V naught by differential input. So what is happening? This is going to become V naught by infinite. Because what is the gain of an op amp? It is infinite. So this is going to become what? VDI, differential input, is equal to 0. Differential input is equal to 0 means what? V2 minus V1 is equal to 0. That means V2 minus V1. V2 is equal to V1. Okay. Then this, in this case, it is going to become what? V2 is equal to V1. So this concept is called as what? Virtual short. Okay. Where the internal resistance is infinite, no current will be flowing here. So virtually they are said to be short. Short means what? The two inputs are connected with a common signal, otherwise the same input. Right? So this is the concept of virtual short and this is the concept of virtual ground. The two concepts will be useful in the all the derivations of the expressions for all the types of applications of op amp. So already the concept of virtual ground we have used in the inverting amplifier, where we have said that VA is equal to 0 because it was an inverting amplifier where the overall the net effect on the point A due to Vi and minus of Vi will be always equal to 0. Nearly equal to 0, a very minute current will be observed there. That's why we will consider it theoretically as 0 only. Okay. So this is about the virtual ground and the virtual short concepts here. So what are we have discussed starting from the inverting amplifier, where the gain of the inverting amplifier we derived is AB is equal to minus RF by RI, where the input is applied to the inverting terminal. Okay. When the input is applied to the non-inverting terminal, it is called as non-inverting amplifier, where the gain we derived is RF by RI plus 1. Then moving to the what? Voltage follower, otherwise the buffer, or also called as what? Voltage follower buffer unity gain amplifier, where we have seen that the input is applied to the non-inverting terminal, and directly a feedback with a direct connection is given to the inverting terminal. There we consider the RF is equal to 0 and Ri is equal to infinite, giving us a gain of AB is equal to 1. When AB is equal to 1, AB is equal to V naught by Vi, so we can say that V naught is equal to V. Okay. So what is the voltage follower? The input and output are equal in terms of gain, equal in terms of magnitude, and also equal in terms of what? Phase. So this is about the buffer, otherwise voltage follower, inverting, non-inverting amplifier. Virtual ground concept, point A is at 0, even though it is not physically connected to ground. The potential at A is 0, even though it is physically not connected to ground. So what is this concept of virtual ground? The situation where the potential at the point A is going to be 0 without actually being connected to the ground. Okay, physically connecting to the ground. Okay. So these are all the concepts we have discussed today, that is inverting amplifier, non-inverting amplifier of using the buffer, right? So I have told you that these concepts are also used in the what we can say numericals. Numericals for 5 marks, where a continuous connection of inverting and non-inverting amplifier will be formed, where you are expected to find the final output. So step by step, stage by stage, you have to calculate the output, and you have to use that output as the input to the next stage, and you have to keep on solving it for the final output. Such numericals will be asked based on inverting and non-inverting amplifiers. Okay. Apart from that, we have derived two expressions till now, that is inverting amplifier and non-inverting amplifier. In the further classes, you will be deriving the further applications. Otherwise, you will be studying the further applications of the op-amp, and also will be deriving the expressions for the same for op-amp adder, subtractor, integrator, differentiator. Okay. So after completing all these, I will be moving to the numericals, 5-mark numericals that are very important for this chapter. So basically, this chapter will be having 1-mark question expectedly. Can be expected to get a 1-mark question, and also fixed 5-mark question and a fixed 5-mark numerical is there for this chapter. Okay. So this is what we have discussed: inverting, non-inverting, concept of virtual ground, virtual short, and also voltage followers circuit. So this is about today's class, students. Thank you.